Recitation 9. So let's see first question. So we have 6 trig functions, right? So which ones are even? Even function means this. So if we input negative x for the function f, that equals to f of x. So one example will be, let's say f of x equals to x squared, right? If we put negative x as the input, we get a negative x squared. So that is still x squared. So that equals to f of x. So graph looks like this, a symmetric with y-axis, or maybe with another vertical line parallel to y-axis. But for x squared, we know the graph looks like this, right? You see, if this is negative x, this is the x, this is the y value are the same. We have this point or this point. The function values are the same. So even function are symmetric with the y-axis. All right, so for just 6 trig functions, we have a sine, we have a cosine, we have a tangent, we have cosecant, which is the inverse of sine. We have a secant, which is the inverse of cosine. We have a cotangent, which is the inverse of tangent. So the even function are cosine, right? The cosine functions. If we call cosine f of x, then f of negative x equals to cosine negative x. That is cosine x. If we think in the graph, when we measure positive angle, we go this way, right? Negative angle, we go this way. But cosine is positive in the first quadrant and in the fourth quadrant. So you will have cosine, let's see, this might be, let's say pi over 4. And this is a negative pi over 4. So cosine pi over 4 and cosine negative pi over 4 equal to each other. Because cosine being positive in the first quadrant and in the fourth quadrant. And also its inverse is, so secant of negative x equals to secant x. Because secant is 1 over cosine, right? And cosine negative x is the cosine x. So that equals to secant x. So only cosine and secant are even functions. Other 4 functions are odd functions. So that answers the second one. Okay, so the other 4, sine, cosecant, tangent, cotangent, are odd functions. Well, let's see, 3. 3 is mixed with the cosecant, secant, and cosine. Well, we know cosine is even. And the secant is 1 over cosine is even. But the cosecant is 1 over sine is odd. However, cosecant squared. So we have a cosecant. If we plug in negative x, however, we get this squared. Because that's negative cosecant x squared. But when we square, it becomes positive. So this is also even. So hence, 3 terms are even. So this whole thing, f is even. Let's see, 4. Write down all the quotient and reciprocal trig identities. For quotient, we have sine equals to 1 over cosecant. Cosine equals to 1 over secant. And tangent equals to 1 over cotangent. Okay. And also we have a tangent equals to sine over cosine. And cotangent equals the reciprocal, right? It's cosine over sine. And also this one can be written as cosecant equals 1 over sine. Similarly for this one, we can write as a secant equals 1 over cosine. Cotangent also can be written as 1 over tangent. So those are the shows the relationship among those 6 trig functions. Now see, we want to simplify the expressions. Let's see 8. Secant, so one of my habits is to change everything into sine and cosine. Secant is 1 over cosine, right? Then divided by, I can write this way. Tangent is sine over cosine. Then divided by a fraction is multiplied by its inverse, right? Multiplicative inverse. That equals cosine over sine. Then we see cosine in the numerator, cosine in the denominator, they cancel each other. So we have 1 over sine. And we know 1 over sine is cosecant. So this is simplified to be cosecant. B, you keep sine, keep cosine is 1 secant. 1 secant is 1 over cosine. Then multiplying by cosine. And this 2 becomes 1, right? Because this is over 1. This in the numerator, this in the denominator, they cancel to be 1. So I'm left with the sine multiplied by 1, just sine. So that's B. C, cotangent equals cosine over sine. Then multiply by sine. Or sine is sine over 1. This in the numerator, this in the denominator, cancel out. So this is equals the cosine. Or cotangent equals the cosine over sine. Then divided by cosecant is 1 over sine. Or division, we change into multiplication. Multiply by sine over 1. Again, this sine in the denominator, sine in the numerator, cancel out to be 1. So left with the cosine x. So again, this shows the relationship among these 6 trig functions. Let's see 6. 6, we want to rewrite this as a single trig function. So basically, we want to simplify this, right? By using these identities, cosine squared plus sine squared of the same angle equals 1. Basically, this is a Pythagorean trig identity. So cosine square x over cosine, right? So basically we multiply, because we need a common denominator to combine those 2 terms. So we multiply by 1, and this 1 is cosine x over cosine x. Then cosine x times cosine x is cosine square x. Now plus sine square x over cosine. So we have a common denominator of cosine. We can add the numerator, the numerators. So numerator is cosine square plus sine square all over cosine x. What's cosine square sine square is a trig identity, Pythagorean trig identity. So that's just 1. There's 1 over cosine. Or 1 over cosine is a secant. Right? So this equals to secant. Let's see 7. 7, we want to verify identity. So we want to verify 1 plus tangent square equals to secant square. So this thing, first rewrite the left-hand side, 1 plus tangent square in terms of sine and cosine. Okay, so we have 1, so let's start with left-hand side. So left side equals to 1 plus tangent is a sine over cosine, right? But we have a square. So we square the numerator, square the denominator. And then 1, because we want to combine those two terms, 1 is cosine square plus divides itself plus sine square over cosine square. So now we have common denominator of cosine square. We can add the numerators. Again, by Pythagorean trig identity, cosine square plus sine square equals 1. So that's 1 over cosine square x. Well, remember that's 1 over cosine x squared. What's 1 over cosine? The secant. So the secant squared, which is equals to the right-hand side. Right? Oh, right. Basically, B is here. Right? I did B in A. So basically, we start when we verify the identity, we start from one side. We'll end at the other side. Sometimes if two sides are complicated, we want to simplify the left-hand side, simplify the right-hand side, so they meet at the same place. So that's a verifying identity. Okay, that's it. That's for recitation 9.